Hello YouTubers. In my last video I discussed using the properties of even and odd functions with the trig functions, okay? And so I did I think maybe okay job of defining even and odd function and showing how profound it might be and how useful it might be, but I think the better idea would just be to go through a few examples and show you why we talk about even and oddness in the first place when it comes to sine and cosine specifically. So we're going to do a few examples. So real quick, let's just review what we mean by even and odd. An even function, if you look up here, is this. An even function is any function that when you plug in a negative x or just some negative value, you'd get the same thing as if you had plugged in positive that value anyways. Okay, so we'd say any function that's even must be true when you plug in a negative x. You get the same thing as if you plug in a positive x. So we would just do the positive x anyways because it's more convenient. So cosine, what we need to know is this. Cosine is an even function. In other words, when we do cosine of a negative angle, okay, so this is a negative angle, that's a clockwise rotation, we can just go ahead and do the cosine of the positive angle because we're just going to get the same thing anyways. And that's convenient because we like to think about positive angles. Now odd functions, we can go and start with this. Sine is an odd function. We already knew this, but odd function means this. When you plug in a negative value into the function, in this case we're saying when we plug in a negative angle into sine, some negative angle, rotate clockwise. We don't like to think about negative angles in the trig functions often, but when you plug in a negative angle, it'd be the same thing as if you took that negative sign, you just stashed it out front and had done the sine of, say, a positive angle in the first place. Okay, so let's go ahead and do a few examples of what we mean here. We can go ahead and check it with the unit circle also, but let's use the fact that say, for example, sine. Sine is odd. You'll often see a math teacher say, okay, use the fact that sine's odd to evaluate the following function. So we say sine. So sine of, say, negative 30 degrees, okay? The interesting thing is, since sine is odd, the very, very first thing I want you to notice is this. Since we're taking the sine of a negative angle, that'd be the same thing as if we just put the negative out front, and we just do sine of the positive angle to begin with. Okay, so sine of 30 degrees. Why would I want to do this? Well, because we know the sine of 30 degrees, or at least, man, I hope you know the sine of 30 degrees is a half, but that'd be the same thing as negative just 1 over 2. Okay, so now we just say, well, then the sine of negative 30 degrees must have been negative a half to begin with. And so I do want to go check this. Let's go over to our unit circle here. If we go negative 30 degrees, negative 30 degrees would have been clockwise 30 degrees. And if you go down here and you look on the outside of your unit circle, of course, sine values are these y values here. We get negative a half, okay? So why would I want to do negative, say, negative sine 30 degrees in the first place? Well, because really, when you talk about the unit circle, the only quadrant you like to memorize is this first one up here. And so we memorize sine of 30 as a half. And all these in the first quadrant are always going to be positive. And we say, well, we'll just use the fact that sine 30 is a half, and we'll just store that negative out front and save it for later. And we did. Okay, so what if we did this time? We say, okay, so sine of, I don't know, let's do one in radians. How about sine of negative 3 pi fourths? That's a good one. Negative 3 pi fourths. Again, the fact of the matter is this. We could just do negative sine of positive 3 pi fourths. We can just deal with a positive angle. That's our intent. We just want to deal with a positive angle. We'll just put the negative on at the end. So we say, what's the sine of 3 pi fourths? Well, I think it's good to illustrate this, but sine of 3 pi fourths, well, pi, of course, is 180 degree rotation. So we have pi fourths. We say, okay, so here's a fourth of pi. There's another fourth of pi. Here's another fourth of pi. We say, okay, so sine of this angle right here, well, this has a reference angle, theta party hat, of pi fourths. Okay, and we say, well, what's the sine of pi fourths? That'd be like over here. So that'd be like radical 2 over 2. So the sine of 3 pi fourths has a reference angle of pi fourths. We could say, all right, sine, well, it terminates in the second quadrant, so all students take calculus. We would get negative. Now we say sine of 3 pi fourths is radical 2 over 2. And we just get negative radical 2 over 2. Okay, so let's go check this on the unit circle really, really quickly here. We said, to begin with, we were doing sine of negative 3 pi fourths. That would mean we'll go 3 pi fourths in a clockwise fashion. So we say, okay, so 1, 2 pi fourths, 3 pi fourths over here. You can see this. And so we say, looking at the sine value, we get negative radical 2 over 2. So if we do it this way, we're basically saying, okay, well, if we put that negative out front to begin with, we could just do sine of regular 3 pi fourths to begin with. Sine of regular 3 pi fourths. Where's my picture? Is it this guy? There it is. So regular 3 pi fourths would have been pi fourths, and pi fourths rotation in a clockwise or counterclockwise fashion. That's positive radical 2 over 2. And then we would have just done the negative last. Okay. So now cosine. Cosine is my favorite. Okay. And the reason why is because it's totally even. So what if I had asked us to do, say, cosine of negative 60, please? Cosine of negative 60, we could just say, hey, guess what? That's the same thing as cosine of 60. Since it's an even function, when we plug in a negative into an even function, it just comes out to be the same thing as if we had done a positive in the first place. So cosine of negative 60 is the same thing as cosine of 60. Well, cosine of 60 is a half. So we say, well, then this must have been half also, 1/2. We could check this on the unit circle. If we would have gone 60-degree rotation counterclockwise, look at the x value here, we get a half. If we would have gone 60 degrees in a clockwise fashion, which is a negative 60-degree angle, you still get an x value of a half. Okay. So how about cosine? We'll do something a little more exotic this time. Cosine of negative 7 pi fourths. Okay, negative 7 pi fourths. Well, we're going to get the same thing as if we had done cosine of positive 7 pi fourths. The nice thing about it being an even function is we can just go ahead and make this positive. So, you know, I think illustrating this would be a good one this time. We say pi fourths. In this case, we say negative 7 pi fourths. That would have been pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths. This would have been a negative 7 pi fourths rotation. We would have landed right over here, okay, and had some x value as our cosine. X. This is our cosine value. Okay, let me say x, cosine x. So what if we'd done a positive 7 pi fourths rotation? We'll just maybe really emphasize this here. We'd go like a different color here. Positive 7 pi fourths would have been counterclockwise. We say, okay, so pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths would have been a 7 pi fourths rotation in this fashion, but we still would have had the same x value on our triangle here, same x. So in other words, you could just do this 7 pi fourths. By the way, which has a reference angle. That's going to have to do reference angle of pi fourths. And cosine of pi fourths is just radical 2 over 2. So you get radical 2 over 2 for this guy and radical 2 over 2 for this guy. We could check this on the unit circle. We say, okay, so check this out, pi fourths had an x value of radical 2 over 2. And if we would have gone negative 7 pi fourths, like it would have landed here, radical 2 over 2, 7 pi fourths would have counterclockwise, rotated down to here, but it still has the same x value. So nice thing about cosine being an even function.